If we want to work out a value for the area of this equilateral triangle, in example A, we can do root 3 multiplied by a side length squared over 4. But before working out the area, it helps to see where this sum comes from and why we can do it. If we look at this equilateral triangle on the right here, we can draw a line for the height. This creates two equal sized right angle triangles. Now, if we focus specifically on one of these right angle triangles and draw it out, not perfect. The base is half of a side length, so the base will be A over 2. And it's at this point that we can refer to Pythagoras, because we can write out an expression for the height of h be the root of a squared minus a over 2 squared, which means that h squared is simply a squared minus a over 2 squared, which we can further simplify more as a squared minus a squared over 4 if we square out what's inside the brackets. Now we can rewrite a bit, as a squared can be written as 4a squared over 4, and we keep a squared over 4 as is. If we carry out this sum we have here, the result is 3a squared over 4. Thus h turns out to be the root of 3 squared over 4. Now this can be written out as root 3 root a squared over root 4, which becomes root 3a over 2. This is the height of the equilateral triangle. Now, if we remember the formula for the area of a triangle, it's half multiplied by the base multiplied by the height, which we have root 3a over 2. So if we multiply this out, we have a half, and we multiply here, it's root 3 a squared over 2. If we multiply again, it's root 3 a squared over 4. Thus the area of an equilateral triangle is root 3 multiplied side length squared over 4, which we're going to do over here, for example A. And if we use an appropriate calculator to do this sum, we can eventually get a value of 6.93 centimeters squared. That's to 2 decimal places. So that is how we can work out the area of an equilateral triangle, provided we know what the side lengths are.